In today's session, we'll discuss the applications and in continuous beam and steps for solving continuous beam and one example problem. So first of all, coming to applications, the three-moment theorem can be applied for the continuous beams with both ends simply supported, and continuous beams with fixed end supports, continuous beam with the end span overhanging, continuous beams with sinking supports. And the steps, come to steps, the first step is to draw the bending moment diagram for the given beam considering the beam as simply supported beam. Second step, calculate area and centroid for the free bending moment diagram. Third step, apply three moment theorem. Step 4 is to find the reactions at the support, and then step 5 is to draw shear force diagram and bending moment diagram. We'll see the first problem in the continuous beam. So continuous beams with fixed end support. So analyze the continuous beam as shown in the figure by using three moment equation and draw the bending moment diagram. You can see the figure given. It is the continuous beam fixed at one end, and the other end it is simply supported, and there is an intermediate support at B. So at A it is fixed, at C it is simply supported, and at B also it is simply supported. The span AB consists of UDL it is subjected to UDL 20 kN per meter, and BC is subjected to 40 kN at center, and AB has moment of inertia 2I and BC has the moment of inertia I with spans 6 meter and 4 meter respectively. So coming to the step 1, assume the beam as simply supported beam and draw the bending moment diagram. Since the given continuous beam is fixed at support A, an imaginary zero span is to be taken to the left of the support A as shown in the figure. So you can see in the figure, second figure there, the fixed support at A is removed and simply supported is kept there, and an imaginary line A0 is drawn. So A0A, the length of A0A is 0 meter. It is an imaginary line. Remaining everything is same. For span A0A, bending moment is 0 as there is no load. For span AB, the maximum bending moment value for UDL WL square by 20 into 6 square by 8 is 90 kN meter. That means moment at D is 90 kN meter. So if you see the figure over there, so in the figure given the question, at A we have a moment, at B we have a moment, and at C there is no moment as it is simply supported at end. So we need to calculate MA and MB. Right, now coming for the span to BC, bending moment at E, bending moment at E, that is at the middle is WL by 4, that is 40 kN meter. So bending moment diagram is shown in the figure. So coming to step 2, this step 2 is to calculate area and center of gravity for the bending moment diagram. So A0 area of A0 is 0, x0 bar is 0, centroid distance is 0. A1 is 2 by 3 into B into H, area of parallelogram, area of parabola, first parabola. So it is 360 meter square. Then its centroid x1 bar from left is L by 2 6 by 2 3 meter, and centroid right side is also the same. So A2 is half into B into H, area of triangle. So half into 4 into 40 with 80 meter square. So x2 bar from left is 4 by 2, from right it is 2 meters. So coming to step 3, step 3 is apply three moment theorem. So we need to apply 2 times here the three moment theorem for A0, A, B and for ABC. First applying for three moment equation or Clapeyron's theorem for A0, A, B. So M0 into L0 divided by I0 plus 2 MA into L0 by I0 plus L1 by I1 plus MB into L1 by I1 equal to minus 6 A0 X0 bar by L0 I0 plus 6 A1 X1 bar by L1 I1, which is equal to 0 plus 2 MA into 0 plus 6 by 2I plus MB into 6 by 2I equal to minus 6 into 360 into 3 divided by 6 into 2I. From here, by solving it, we will get 6 MA plus 3 MB equal to minus 540. Let it be equation number 1. Next, applying three moment theorem for ABC. MA L1 by I1 plus 2 MB into L1 by I1 plus L2 by I2 plus MC L2 by I2 equal to minus 6 A1 X1 by L1 I1 plus 6 A2 X2 by L2 I2. Here also MA and MB are the unknowns. We will get one equation 3MA plus 14MB equal to minus 780 after solving it. So let this be equation number 2. Now solving equations 1 and 2, we'll get MA as minus 69.6 kilonewton meter, MB as minus 40.8 kilonewton meter. So minus indicates that is hogging. So we know that at the supports there will be hogging. So minus. Next step is to find the reactions. So take the span A, B, C and take the separately. Take AB and BC separately. So for AB, let us calculate the reactions, and for A, B1 and B2C separately. So if I take AB span, I'll apply sigma MB equal to 0 and sigma FY equal to 0, and I will find here RA and RB1. And if I take the second span B2C, here I will apply sigma MB equal to 0, sigma FY equal to 0, and I will find RC and RB2. So RA we have got, RB is the sum of RB1 and RB2. So RB value is RB1 plus RB2. So RC equal to 9.8 kilonewton, RA is 64.8, and RB is RB1 plus RB2. So here if you observe at A, at B there is a hogging. So we have represented for AB it is clockwise, at B it is B1 it is clockwise, and B2 it is anti-clockwise. So RB equal to 85.4, RA is 64.8, and RC is 9.8. So now we can, as we know the reactions and calculating the shear force values, we can draw the shear force diagram. So shear force at A is 64.8 and at B is 55.2, and then at B it is 30.2, from B to E 30.2, and then from E to C it is 9.8 minus plus, signs are shown there. And then we can draw the bending moment diagram here. So bending moment diagram is very easy here. Just in the starting step we have drawn the bending moment diagram for simply supported case. So same we represent here, but we add here the fixed end moments also. That is MA 69.6 we got minus 16.6. So 16.6 minus B at MB minus 40.8, and then we'll join the line there, and we'll represent the minus and place signs over there, and there completes shear force and bending moment diagram. Thank you.